Okay, welcome back. We'll continue our session, and the next is Tomas Kirnak, and he will be telling us how to manage 1500 MikroTiks with a single click.
Hello, everybody. So this is the prime spot, the second day after lunch. So thank you very much for being here. I expected a half-empty room, so this is much appreciated. Okay, so managing 1500 routers with a single click. This is a network automation tale. My name is Thomas. I'm a system architect, some other stuff as well. I'm here with Unimus, which is a network backup and management solution. I have a stand down there, so if you want to talk to me about it, feel free to stop by. So this presentation is actually an hour long originally, and we have 45 minutes. So a few disclaimers. I speak fast, and as you probably noticed, I have a lovely Slovakian accent, so I do apologize in advance if you don't understand some of my rambling. Also, we won't have any time for any questions, but if you have questions, I would love to talk to you after the presentation. You can find me in the exhibitor room. So, why are we talking about this? Network automation is definitely the way to go forward. And there is sadly very little material around the internet on how to do it properly and what are the challenges and what are the various options and etc. etc. So that's why we do this talk. I recently completed a project that deployed 1500 MikroTiks in a nationwide network with full automation. So this is going to be a tale about that project and how it went and what were the challenges, what we did and how we did it, etc. So yeah, let's talk about how automation can make a project like this or any other similar project or whatever you guys do on a daily basis. How can it make your life better? So disclaimer number 2, the actual project and the entire solution I did for the 1500 nationwide network is under NDA. So I cannot show you sadly any actual screenshots or the demo of the system. But I did receive approval to talk about the system and to tell you the implementation specifics. So I can tell you enough to explain what you need to do, how it works, why it works that way, what are your options, etc. So massive thanks to the people who cannot be named due to the NDA for allowing me to even present as much as I can. I promise you, it's not cut down in any way. We will get very technical. There is lots of stuff. It's just no actual screenshots or the demo of the system. Okay, so yeah, let's talk about network architecture. So let's start with the architecture, right? How are we going to do this? What are we even doing in this particular example, in this particular project? So first of all, the backend. For us, this project, this particular network provided some private services to 1500 sites around the entire country. So it was not public services. We had a data center, and in your data center, this is, of course, just an example of how to do things on the backend. This is not at all you should do it this way. This is just one example. Of course, there is many different ways to architect things. But the thing that I want to highlight here is You may or may not want VPN access concentrator in your backend, in your data center, to terminate all of the clients. You may or may not. That depends on the next slide. So that's one important thing. Internally, of course, down here, you can have multiple subnets, DMZ management, DMZ 1, 2, 3, etc. You know, this is the actual subnets, the actual networks where all the servers and the services live in, which are offered to your customers and or clients. And of course, your servers and your SAN and everything else that we see in here should be redundant and redundantly connected. That's why we have such a spider web here, right? Any services that you have to offer with an SLA that have to be highly available, etc., you definitely want redundancy. Since we are talking about redundancy, one really important thing is if we are talking about the high availability scenario with SLAs, you really want to have a failover site. So a second failover site somewhere else, different data center, different, if you are in the cloud, in the AVS, different availability zones, etc. Don't rely on a single site to provide very high availability services. There is, I hope I don't have to explain why, right? Okay. So this is just an example how to architect stuff in your data center. Down here then you would have one or multiple DMZ subnets where your actual services live. As I said, it's not as simple as this. This is just an example. So let's talk about transit now. How do all of the clients from the different 1,500 sites around the entire country get to those services that your servers down here offer? So that's the second thing. Basically here you have three options, right? First of all, you can build your own transit network. Yeah. So this is not going to be realistic unless you have a lot of time and a lot of money implementing your own national-sized transit network. It's not a very good idea, usually. So let's go to more realistic options. So you can buy WAN services from a carrier or a provider from a nationwide network that is already built up. You purchase dedicated transit WAN services. Or the second realistic option is just use the internet, right? So these days, everybody is connected to the internet. There is a very high chance the sites that you are connecting already have internet. So let's talk about these two options, because we said first option, not really. So if we are talking about a nationwide network, option 2 will provide us with the best stability, with SLAs, and mainly with consistency, right? If you purchased a single service that's nationwide from a single provider, dealing with them is going to be quite easy because they will want to sell you that wholesale big service, right? So you can get consistent SLAs across the entire topology. You always deal with just one entity, with just one network provider that is offering you those WAN services. And consistency is a big one, especially since we are talking about an automated network, about an automated infrastructure. So when you get that consistency of knowing that every single site is connected through the same mechanism, whether that be PPPoE or DHCP, or how is it subnetted, do I get publics, do I get, when you get that consistency, which you get from buying the single service from a nationwide network, it's really nice for automation. Of course, the downside of this is that this will be quite a bit more expensive than just using the internet, which everybody already has. So let's talk about the option of using the internet. So option 3 will be the cheapest one, although the most problematic one. So first of all, you are no longer dealing with a single entity. You are now dealing with a bunch of different providers across the entire country that all offer potentially different speeds, different connectivity options, different billing, different SLAs, different support, etc., etc. So here, the choice of what you actually do depends, of course, on the project scope, the money that you have available, how much SLAs, how much availability you need to provide, etc. So, yes, that's pretty much the options that you have, the other two. So what did we do? We actually purchased WAN services from a nationwide carrier, from a local incumbent company. And yeah, that's it. We had nice consistency, consistent SLAs, dealing with a single entity, all of that. So we have the backend, we have the servers, the data center, we have a way to connect our sites across the entire country to those services. So let's talk about the architecture talk, part 3, the users. The sites, the individual networks around the entire country that you are connecting through this transit network to your services. So yeah, here actually there is many issues awaiting. So how do you architecture this? How do you architecture those 1,500 different networks? So this depends on the choice of transit method, right? Because you would prepare and you would architecture and you would think about this differently if you use the internet for transit and if you have consistent WAN service across the country. It also depends on if you are building a new network or if you are interconnecting existing sites which already exist across the country to the new service which will be provided by the whatever service you terminate at data center. That's also a big differentiator in how you think about this. And the final problem is, do you even have full control over the customer sites? Can you dictate policy to them? Can you dictate subnetting? Can you dictate what devices, what routers, switches, etc., what they use? Because in certain projects, you might not be able to do that. In others, you will be able to do that. So all of this is, it changes how you architecture the entire system. So what about us? What about this particular project that I did? How did that work out? So yeah, we were interconnecting existing sites around the country that were already set up, already had internet, and they were set up somehow, meaning this. This is not good. All sites already had internet from various providers with various cheapest brand routers, with various speeds, various quality of service, various things. So this is our case, right? So how do we deal with this, right? We theoretically could have tried to force unified addressing to get around subnetting issues and duplicities. And we theoretically could have tried forcing new routers, so forcing router change on every site. But let's be realistic. So if we actually wanted to do this, it would drive the timeline of the project and the costs of the project extremely high. Also, suddenly we would become responsible for dealing with all the change that needs to be done to all the 1,500 local networks. And they had different things in their networks. They had servers, some had, whatever. So suddenly we would become responsible for dealing with any issues that came out of that change that we were forcing on them. And you can imagine, yeah, time equals money equals project issues, etc. So this was our case. So you can see how this is actually a very complex debate with many options where you need to choose the proper solution for the proper use case, do the proper analysis before, etc. So yeah, this is what we had. And so what was the other solution to this problem? So in our case, the simplest, cheapest, and fastest solution was to add another MikroTik to every site. This is not at all a perfect solution. But if something is the simplest, cheapest, and fastest, it's really hard to argue against. So we actually added a second MikroTik to every site, which we connected through our transit services provided by the nationwide provider network. This meant we didn't have to touch existing routers and existing networking at all, which means we avoided having to do change on 1,500 sites across the country and dealing with the consequences of that change, which would have been huge. And also, this was not the scope and the part of the project. There was no money in the project to overhaul 1,500 existing sites. As I'm saying, this is not perfect. It's far from perfect, but in this case, it was the valid solution. So yes, minimal change to existing networking, minimal change to sites, minimal impact. So yeah, other problems. So what are the problems with this solution? First of all, what about routing, right? We are adding a second gateway connected to the local network that now devices need to use to access our services, because our services are only available through this gateway, not through the public internet. So what about routing? And luckily for us, all the client PCs, all the devices that needed to access these private services were in Active Directory, meaning that a single GPO actually took care of all of this. So what did the GPO do, right? On all the devices, it deployed a route to the subnet, which we terminated in the data center, to go over this new router. And the default route kept on through here. So again, this is not a perfect solution at all, but a valid one for this use case. So if this was not the case, if we didn't have the option of deploying a GPO and influencing the routing at the end devices, we would have probably had to architect the entire solution differently, right? So here you can see how proper tools for the proper job, right? So we were able to get away with this because of Active Directory and because of the GPOs. And again, it's really hard when you talk to project manager and the project owners. If you offer the simplest, fastest, cheapest solution, what are the options realistically, right? Either we had to overhaul the entire 1500 sites, force addressing, force router changes, etc., or we did this. So yes, that's our problems 1. So our problems 2. What about subnet duplicity? And because we said the existing sites were already set up somehow, usually with this, which is of course a problem if you want to get back from the data center to inside of the sites, right? So this is a problem which NetMap is the answer for. So NetMap creates a one-to-one static mapping of one set of IP addresses to another. So we basically created a unique virtual subnet for each site. And then we use that virtual subnet with NetMap to assure addressing uniqueness. This just meant that every site, the virtual subnet, if you connect it to IP address .11 on the virtual subnet, it would go inside the network to the duplicit networks, but it would actually be unique from the point of view of our infrastructure. Does that make sense? So, again, not the cleanest nor the best solution, but a valid one. It works. It's sometimes even if you architect things, you might not like it, but you have to make compromises if, what are the other options, right? So if the project scope was like this, you have to make it work, and this is a valid solution, although not the best nor the cleanest one. So, a little tangent. I love tangents. Where is IPv6 when you need it? So IPv6 would have made this whole project so much easier. It would have been designed completely differently. None of the netting and the secondary gateway and all of that would have been needed. But sadly, our oldish existing networks are far from IPv6 ready. The various random internet providers at each site are also far from IPv6 ready, which means that at some point in the future, when IPv6 came along, we would have to reconfigure the entire topology, right? Because we would have to readdress. And yeah, there wasn't enough money in the project to allow a full IPv6 deployment. Excuses and more excuses. What I want to get at here is that IPv6, there is no avoiding it. We all just need to do it. Let's start doing it, please. It would have been so much easier. Anyway, tangent over. So MikroTik to the rescue, yeah, because it's the right choice. So MikroTik is ideal for a project like this. It has an awesome feature set, everything that we need for this project and much more, and the best price-performance ratio you will find. Imagine how happy the management will be when you tell them, when you are deploying a network of 1,500 routers, the difference between deploying 1,500 insert big vendor name routers and 1,500 MikroTiks, it's a 10 to 15 times cheaper to deploy the MikroTiks. So yes, and MikroTiks are actually great for automation. We will get to that later on. So let's talk about what we want to achieve here. Now that we've talked about the architecture, about the problems of designing the entire solution and the entire system and interconnecting 1,500 sites across a nation, let's set our goals to automate what we want to do. So let's look at how we would do things without automation and how can we implement and design automation to help with a project like this to make our lives easier. So the traditional approach, the deploy. So if we want to deploy a network like this, Network admins would configure the routers somehow manually. Let's say 5 minutes per router times 1500 routers equals to about 16 workdays, which is realistically a month, since 20 workdays in a month. So it would be a month just for a network admin to configure 1500 routers. And I know you can automate it, you can script, you can flashfig, but let's talk about a pure traditional approach without any automation, without any scripting. So then, those routers slowly get configured, they get put into storage, and then the installers, the tech, slowly take out the routers, go to sites and install them, right? So if there is a problem at site X, because, problem X at site Y because of Z, something is wrong. The site reported how their internal architecture wrong, etc. Many things can happen. Or just the networking admins, they had 1500 routers to configure. It's manual work. There is an issue in the configuration. It creates wait time. And wait time is not good, because the tech that installs it has to create tickets, has to get the hold of networking admin, they have to debug, somehow remote access, blah, 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 just wait time, right? And so that is problem one. And the problem two is we are deploying 1500 new boxes, one new box at every single site. So you can be sure there will be requests of, can this new box also do thing X? For us, for example, a lot of the existing sites didn't have Wi-Fi. So since we were already deploying a new box, why not also give them Wi-Fi to their network, since they didn't have it previously, right? The box can do it, so why not do it? It's a benefit to the user, makes the user happier, and happy users mean we have a happy life as well. So if this happens, again, the tech or the installer needs to get a networking admin, which needs to connect somehow, needs to configure Wi-Fi, then the SSID and the pre-shared key needs to be distributed to the users, etc., etc., etc. Okay, so now that we've deployed our entire network, a network needs a maintenance, right? So the deploy is just part one. The second part, you need to take care of the network. So you need to upgrade router OS and router boot. So let's calculate, 2 minutes per router upgrade times 1500 routers. So it's about, almost 7 workdays per single version upgrade rollout to the entire network. Again, we are talking traditional approach, no automation, we are doing it manually. And you guys know, I hope everybody knows, recently there was a big leak from a certain US government agency thing. Which one? I don't want to say their name, because then I will get it on record that I talked bad about them, and they will not let me back into the country past the wall. So yeah, you need to roll out new versions. Let's just consider you need to roll out a new version every 3 months. I think that's fairly realistic, right? So that's 4 version rollouts per year, which means you have 7 times 4, right? Let's do the math. That's 28 work days. So that's more than a month of realistic time per year just on version upgrades. And time equals money, so you can imagine how much this actually costs in network maintenance. Okay, so upgrading router OS and router boot, yes, sure. But not that often, once every 3 months or even less. Okay, we just upgrade our network once a year, okay. But what about deploying configuration changes? This is something that you will have to do fairly often. Your policies change. Your auditing shows that something needs to be reconfigured, the networking topology changes, whatever, or you get new compliance requests that require you to change your configuration. So here we assume 1 minute for a configuration change per router, which comes out to 3 work days per configuration change. This is a killer. To deploy 1 line of code across the entire infrastructure is 3 days. And not just that, you can imagine if first of all, that's like the worst job to get. Imagine you as a network engineer, here is a line of code deployed at 1500 routers. It's the worst monotonous repeating job you can get, right? Nobody wants to do that, right? You can be sure that if this is done manually, there will be, if just 1% mistake rate, what's 1% in 1,500 routers, right? Yeah. That's actually a fairly decent chunk of the network that's now getting inconsistent, wrong configuration. So, yeah. And again, we are not talking, yes, I know you can automate it somehow or fully. We are talking about the full traditional approach. And something specific at site X. For example, client side number 496 wants to change their Wi-Fi PSK, pre-shared key password, right? Or they want to change their SSID, or etc., etc., etc. All of this is manual. So it creates support center calls, it creates tickets, manual network admin work, potentially different configuration at each site. The consistency of the entire infrastructure just goes completely wrong. It's a nightmare. So, yeah, that's the traditional approach. So let's look at automation. Let's look how we could use and prepare automation to improve all of this. So first, the deploy. So before we even start, we put an automation system into place. We prepare our automation system, and then we feed data to a CMDB. CMD is a configuration management database. So it's a database which keeps data about your sites, about your networks. And this is just run a whatever SQL script, and the data entry team is responsible for this. It's not our job, and as we know, data entry is much cheaper than network engineering, right? So we prepare our automation system, feed all of the data that it needs into a database. Then techs go out, or installers go out to every single site and install the hardware. And after they do that, they just click a button in a nice web interface to provision all the configuration to the router. That's it. No actual network administrator work involved. And to solve the thing of can this box also do X or site-specific things, we deploy a self-service portal where end users can actually change various things. For example, enable, disable Wi-Fi, change the SSID, change the pre-shared key, etc. So the self-service portal allows our users to, on demand, without any support center calls, tickets, anything, change certain various configurations on their router. When they do that, they log into a nice web interface, they change their password, they click save, and the automation system instantly automatically provisions the new configuration on their side router. Much more friendly, right? You can imagine, it's the users. You guys know how it's dealing with the end users, right? They don't want to call you. If they call you, then it's I have to talk to the IT guys again and all of that. No, it's we let them do whatever they want. They have a system where they will not break anything. We have chosen what we have allowed them to change. So it makes, again, our users much happier. Happy users means we have little issues and we all get paid and etc. So that's a deploy. Let's look at the maintenance. So upgrade router OS on the 1,500 routers, it's actually 1 click, 2 minutes. That's it. Because you just click a button and the automation system does everything. Deploy a configuration change to 1,500 routers. And that's actually 1 click, 30 seconds. And it's done. Something specific at site X, we want Wi-Fi. Well, we don't have to deal with that anymore. Users have their self-service portal where they can do this. Right, so immediately, automatically provisioned, the users immediately see feedback, see change, they are much happier, they can do things on demand, it lessens the workload for us, etc. So there's a lot of benefits. What we haven't even talked about is the consistency that we achieve. Since this is done through automation, right? Humans, we are not perfect, nobody is, so we make a bunch of errors. So human error here is eliminated. We make errors, machines, they make less errors. So consistency is achieved across the entire network. All the configuration everywhere is the same because it's automatically put into place. Client customer satisfaction is much improved. The wait times and the ticket numbers we get and the support center calls we get are much less now. So yeah, welcome to the dreamland, the automation land. And I know it's not as simple as I make it sound, but so yes, automation is much cheaper in the long run. If you consider, like we said, the router OS deploys 6 days per upgrade, that's with automation, that's 1 click, 2 minutes. And you know it's done consistently, it's done the same everywhere, it works. Because the automation system assures that the version is deployed, it checks all of the things that are needed, etc. Also, think about, if you have 1,500 sites which you don't have full control of, like we have in this project, at any given time, 5 to 10% of these sites might be offline. Power outages, somebody decided to unplug the router because they needed something else plugged into the, power socket, right? So it has much benefit in the fact as well that since it's automated, the system actually just checks back. If a router is unreachable, it automatically checks back in 10 minutes, and every 10 minutes from now on, it will try to upgrade that router until it succeeds. With us, we would have to, if we did it manually, we would have to manually somehow keep track of what is upgraded, what is not. We would have to come back to it. It's just a mess. So the automation takes care of it for us. Much healthier network. Why? Because of that consistency. Because of the assurance that I know for a fact that a certain configuration is deployed everywhere, and there are no errors from manual deployment of configuration changes, etc. Yeah, mass changes, mass upgrades are now painless, and you actually come to see the network in a different light. Because if your requirements change, if you get a new compliance policy that you have to comply with, or if you just don't like how something is configured, now you don't have to think about the price of 3 days of reconfiguration you have to pay to make any change. It's actually 1 click, 30 seconds, and the entire network of 1,500 routers is now, fixed for whatever issue we're trying to fix. So, yeah. Also, this is actually a data-driven approach because analytics can now be ran on your CMDB data. The analytics can show you various things across all of the sites, across, how do the configuration change when sites are online, offline, blah, blah, blah. And this goes also back into monitoring. But the point is, it's now data-driven approach, code-driven approach, rather than a bunch of manual stuff which somehow works. So yes, I am a WISP or an ISP. How does all of this apply to me? So even as an ISP, you will inevitably have cookie cutter configs. So configs which are the same, just very slightly different. Customer CPs and our customer routers, brasses or PPPoE access concentrators, APs and wireless bridges, switches, tons of switches, right, etc. If you think about it, the configuration is not that different. Like, what do you guys do, right? You just have a template which you fill a bunch of things, paste it into a router, or you have some flash fix scripts or something, right? It's not that different if you think about it. So yeah, you should at least consider automating configuration provisioning and management of all of these. So this is what we are going to talk about now. When should you automate and when should you not? When is it worth it for you to actually even consider getting into all of this automation stuff? So I would myself consider 3 base metrics for when to consider an automation system. So metric 1, time to implement automation versus time to do the task manually. Metric 2, cost to implement automation versus cost to do the task manually. And time equals money, but actually these 2 metrics are separate. We will get to why in a little bit. And metric 3 is what other benefits will I get by automating which I wouldn't have otherwise, and do those matter to me or not? So we are going to talk about each one of these in a bit more detail. So, time to implement automation versus time to do the task manually. Do not forget to account for the initial deployment, but also for all the maintenance that you need to do in the future. So with any sizable network, 300 plus devices, automation will become favorable really fast in this metric. But it also depends on if you are automating an already existing network or automating a network which you are building from scratch. Because, of course, if you are automating an existing network, the initial deploy is not there. We already have some kind of a deploy. But what you need to consider is, what if you want to migrate your network to a different topology? For example, you want to start implementing MPLS, VPLS, or you want to migrate from EOIP to VPLS, right? In the complexity of this migration that you need to do is actually comparable to deploying the network from scratch again. So if you have automation, this can be easily achieved at 3 a.m. at night with one click, and suddenly your entire network is migrated from EOIP to MPLS VPLS. And I know I'm making that sound very easy. I know it's not as easy as I just described it, but the point is you can actually do that and minimize the customer impact such a migration would have if you have automation that with one click at 3 a.m. will migrate the entire network, rather than doing it slowly over time, manually reconfiguring, etc. And again, I know it's just not as simple as I'm making it sound, but you know. So yeah, that's metric 1. Metric 2, cost to implement automation versus manual cost. And this can be hard to calculate because it depends on many factors. First of all, cost of developers versus cost of network admins. In some areas, developers are cheaper than networking engineers. In other areas, it's the other way around. Even availability of the right developers. Can you get developers? Or the cost of migrating your network engineers to NetOps engineers. So the cost and the time that's required for you or your networking guys to learn scripting and learn automation, etc. And another big factor is the complexity of the automation system itself. In very unified, homogeneous networks, automation is easy to make. In networks which are very complex, very diverse, the automation system you will require to automate provisioning, upgrades, etc. of all of those networks, you can imagine is much more complex, and there will therefore require much more time to implement that automation system. So yes, with large-scale uniform networks, this metric is very favorable to automation, but in smaller scale or complex, diverse networks, this metric is less favorable to automation. And metric 3, other benefits of automation. So factors like elimination of human error, factors like unification of configuration across your network. Okay, how many of you guys have consistent firewalls across your entire network? By this I mean that the address list for the administrator IPs is named the same everywhere, the basic structure of the firewall, the chains that you use. How many of you have all of that consistent across your entire network? Come on, raise your hands. Wow, that's actually very good. So about 10% of you, maybe more, 15% of you raised your hands. That's actually very good. But for the rest of you, consider that, right? Because automation will make it that way, since there is no more manual deployment. And again, I know it's not as easy as I make it sound, because of course the firewalls will be different on subnet terminating routers, on transit routers, on PPP access concentrators. I know it's not that simple, but at least the basic structure of the firewall, the chains that are there, the input firewall, the address lists and how they exist and their names and their contents, all of that can be made very easily consistent with automation, and it can be very hard to maintain all of that manually. So yeah, one-click provisioning, one-click configuration changes which are instant across the entire network, software upgrades on mass scale that now become non-invasive operations, because you can schedule them at 3 a.m. every night, which has very little customer impact, and they will be immediately applied across the entire network. Yeah, improved network and service quality due to that consistency and all of that. You can offer better SLAs, and I could go on. The point here is that in all of these metrics, automation is a big win, and it is something that should be considered if the automation is worth doing or not for the benefits you can get. Of course, together with the other metrics that we have here. Okay, so what's the conclusion? I'm a big pro-automation enthusiast. I automate everything, even stupid things which should never be automated. I automate them anyway because I hate manual repetitive tasks. So yeah, I honestly think, based on the facts and my previous projects and previous experience in the field, that automation is like 95% of the time it's the right call. Of course, you have to know how to script, you have to know how to automate, or you have to pay people to do that. I'm not saying it's easy. But yeah, and we can see this is not just my opinion. All other fields of IT are moving towards automation. DevOps is all about automation. Infrastructure as a code. There is frameworks like Puppet, Chef, SaltStack. That's all about automating service deployment, etc. Virtualization. Containerization. And I know that's not just about automation, because virtualization and containerization are about many things, but it's also about automation, right? You deployed VM from templates. You click a few buttons in AVS and you can have 10 virtual machines deployed immediately. It's also about automation, about the speed of deployment of services, etc. So yeah. Consider all of the metrics that we mentioned. Don't forget about the challenges, and this is, I'm not saying it's easy, but decide for yourself if it's worth investing time and resources into. I think in many cases you will find it is. So yeah, let's now stop with all the non-specific, non-technical things, and let's go into the technical. So automation basics. Let's start from the beginning. Sorry? What? Okay, yeah. Oh yeah, we have to hurry up. So, the anatomy of a network automation system. Component 1, CMDB, Configuration Management Database. And SelfService Portal, which allows users to change settings in the configuration database. Component 2, which is the Network Monitoring Management System, consists of a provisioning system, monitoring system, upgrade system, and some way to synchronize all of the devices from CMDB to the NMS. And component 3 is a backup system. So we are, of course, not talking about the backup system for your servers, which you should have anyway. We are talking about the backup system for the configuration of your routers. And also some way to automatically get all of your routers from CMDB to the backup system. So here is a nice little diagram. Users are down here. They interact with the self-service portal, which changes things in CMDB, which then the provisioning system takes and provisions onto the routers, and you have backup of our configurations. So yeah, why backup? Well, first of all, it's the last line of defense for you. Even if you have automation, having backups of the actual proper configuration that you know was deployed on your devices and worked at some time is very useful if your automation system breaks for however many reasons. And also it can be really good for disaster recovery. So you can actually have backups off-site, somewhere separate. If your everything breaks, last line of defense. So yeah, CMDB, we said it keeps data about our routers, unique things like IP addresses, gateways, Wi-Fi stuff, etc. And then the self-service portal, which allows users to change these things. One nice thing is, now that you are teaching your users to use that self-service portal, you can actually also include health of the entire system inside of the self-service portal. Are all the services up? Is there a known outage in the user's region, etc., etc.? So you can actually teach users to, instead of just, the wheel is spinning and it doesn't work and it doesn't work, you can teach them to just check with the self-service portal first. Because, users, they don't like to call, they don't like to make tickets, this way you can actually teach them to have that instant gratification of knowing if there is an issue, that there is an issue. And you can even do things like, we have already dispatched a tech to change your router because it fried or something similar. So this goes into a business side of things, but we don't have time to talk about that. Let's continue. So what did we use in our project? We used existing inventory system as the CMDB. I'm not going to talk more about that because of time limitations, and we wrote a simple web GUI as a self-service portal. This is really easy for any good developer. This is 2 days of writing code for an experienced developer. Just remember security, security, security. So properly engineer it, HTTPS, username, password, blah, blah, blah. So component 2, the NMS. This is the heart of our system. It makes sure all of our routers are on the right router OS version, handles upgrades, mass upgrades later on if we need them, then takes care of the provisioning of configs to new routers or provisioning configuration changes to all of the routers. And then we have full monitoring of our entire topology. And as you guys know, I am the monitoring guy. If you have ever heard any of my presentations, I can go on, and as Greg has said, I have gone on previously on other long rants about monitoring. So yes, proper monitoring is absolutely essential. In fact, it's so important that I have a separate MOM presentation just on monitoring. So if you guys want to see that, it's right here. The difference between I think everything is okay and I know everything is okay for a fact is huge. And my favorite statement, which I have had some people argue with me about, is that I honestly think monitoring is the most important thing in your network other than the network itself. And I will be happy to argue with you on that point. Anyway, yes. So have a proper monitoring. And so what did we use? We used NetXMS as the NMS. It's an open source NMS system, very flexible, extensible. See the previous linked MUM presentation. And we wrote our own provisioning and backup scripts. For the proof of concept system, this was just some TLC and expect scripts. And for the final solution, it was Java with JShell and expect. Yeah, so we use an existing open source system and extended it to have provisioning and upgrade capabilities with some custom code. On the MikroTik side, RouterOS is really comfortable to automate around. Simply, upload the config file and run this command, and suddenly that's it. Your router is now provisioned with the new configuration. So we need some way to get all our devices from CMDB to the NMS. For us, this was a simple, little application which synced routers into NetXMS. The CMDB and NetXMS have APIs, so it was a little application connected to the API on both sides, sync the state between those. So backup system, we talked about that, so I will just skip that. So what did we use? We used Unimus, self-promotion warning, it's our product. But you have other options like Rancid and Oxidized, or you can just write and script your own. If you would like to talk to me about this or why Unimus is better than the other options, come and see me later on. So yes. Then of course you need some way to automatically get all of your routers into the backup system, so to synchronize all the devices between all of the systems. So yeah, for us, Unimus already has a native NetXMS connector, so that was just a couple of clicks, and that's it. So you manipulate CMDB only, everything gets synced between all the rest of the systems, and users can manipulate what configuration gets deployed. Oh, we made it. So the demo, this is usually where I would demo how the system works, but I can't due to the NDA. I would love to show you, but I can't, so I will just tell you how it works. So when adding a new router is added to the CMDB by the data entry team. So the data, and there is some business processes which are associated with bringing a new site up. As a part of those processes, the data entry team enters all of the information for that site into CMDB. As we know, that information gets synchronized to the provisioning system and the backup system, and so a installer, a tech, simply picks up an empty MikroTik that has absolutely, it's fresh out of the box. Nobody has touched it before as it came from the distributor. Picks it up, goes to the place, connects it up, goes to the provisioning system, clicks provision, done. Yeah, I know. So, yeah, much faster, simpler, streamlined, much more processed than the traditional approach. Much less errors. Ensures consistency, all the things that we have talked about. When a client wants to change something, they simply go into the SelfService Portal, click buttons, change what they want, click save, and the system provisions immediately to the router, which means that no tickets, no networking administrators ever touch it, etc. It just happens, right? Data are updated in CMDB and provisioning happens automatically. So yeah, you can imagine how for the end users, this is a much friendlier process than having to create tickets, support phone calls, etc., etc. And the customers get that gratification, that satisfaction, that immediately things that they want to reconfigure, they can do it. It happens immediately. Security is not compromised because we chose what configuration options they can change, etc. So, yeah. When updating routers in entire topology, how do we do that? Because software updates are needed, a network admin simply logs into NetXMS, into the NMS, selects a group of routers or the entire 1500 router topology, clicks upgrade, and 2 minutes later the entire topology is upgraded because it's all automated and it just happens. So, of course, this assumes that we tested everything previously in a lab. You don't just roll out a new version of software to 1500 routers without testing it first. Please don't do that. And yeah, the automation effect again, imagine how difficult this would be without automation. In fact, we calculated how difficult and long that would be about 20 slides ago. So, and again, we have consistency, attack surfaces are decreased, we haven't even talked about security, we don't have time, etc. So, when we want to provision configuration changes to the entire topology, we simply write a configuration change to the base template or templates and click provision. Yeah, and that's really it. About 1 minute later, the entire topology of 1500 routers is running on a new config. Of course, this again assumes that this has been tested previously in the lab. There are change processes, change auditing, approval of change, etc., etc. Yeah, this would be a nightmare without automation, as we have talked about, time, errors, etc., etc. The point is, consistency is achieved. Attack surfaces are again decreased because of the consistency we have achieved. Our network is much more defined, since we know if there are attack surfaces, they are the same across the entire network. And if some attack surface has been eliminated, we know it has been consistently eliminated across the entire network. And reaction time to change requests is massively decreased. The fluidity of the network, how elastic your network is and how fast you can apply changes becomes much easier, much better. So that's it. Yeah, things to watch, listen to, and I promise I'm done. So yeah, I have a bunch of other presentations from moms that I did. You can find it on YouTube, more self-slash promotion, so you can find this on my YouTube channel. And yeah, I am a part of the Brothers Wisp. We are a bi-weekly podcast. Hello, everyone. Woohoo! Yeah, you can find us here. Give us a listen if you like. And that's it. We don't have time for any questions. So if you don't understand anything out of this crazy stuff, just come and talk to me afterwards.
Thank you. Thank you, Thomas. And the next will be Justin Wilson, and he will be talking about high availability